Welcome back. Today we're doing problem 146, LRU Cache. This is actually a problem that I saw during an interview with TikTok. So it's a relevant problem. It's probably being asked by other companies as well. So let's get into it. Design a data structure that follows the constraints of a least recently used LRU cache. So when we implement the cache, this has a capacity. Initialize the LRU cache with positive size capacity. And it supports two operations, get and put. So get, it's provided a key, and you're supposed to return the value of the key if it exists. Otherwise, return a -1. Put, so given a key and a value, update the value of the key if it exists. Otherwise, add the key value pair to the cache. If the number of keys exceeds the capacity from the operation, evict the least recently used key. So we'll go through an example, this example actually in a second, but the approach that we're going to take, first of all, let's look at the operations we have to support, right? When you see an operation like this with a get, at least in my mind, you want to be able to return values quickly. So you kind of want to maintain a mapping. So initially the mind jumps to, okay, let's use a dictionary. But the difficult part about this problem, and the whole point about it, is the eviction process, right? How do you maintain which items in your dictionary are the least recently used ones? So honestly, for this problem, I saw it a long time ago, and when I saw this, I was like, what the hell, like, what am I supposed to do? I just looked it up, like, how to do this problem, like, a really long time ago, and honestly, what stuck to me was this thing called ordered dictionaries. In Python, there's something called collections that you can import, and you can use ordered dictionaries which retain the order in which things are added into your dictionary. And it also supports operations for when you're accessing them, you can move the key value pairs in your dictionary to the front or to the back as you see fit, right? So before we do that, let's go into an example with this example here so that we can understand what the problem is actually asking for a little bit better, right? So let's say that these are the operations that we've received. And assume that, like, we're using some kind of ordered dictionary, and this is what our cache should look like, right? So actually, this is not a good representation. Let's just say we haven't even discussed ordered dictionary. Let's just talk about how the cache should look like when we actually perform these operations, yeah? And so what we're gonna do here is on the first operation, we have a put. So let's say we put this value in, yeah? 1, 1, with this key 1 and this value 1. Then we have another put. So we put in 2, 2. So now our cache looks like this. Then we call on get 1, okay? When we call on get 1, what should that do? That should look into our cache. It sees that, hey, 1 is a valid key inside the cache. The value associated with that key is also a 1. And so when you call on a get, you should be outputting a 1, right? But our cache now has just used this 1. So if we retain order left to right, where right is the most recently used and left is the least recently used item in our cache, technically, our cache would no longer look like this after the get, and we would have something that looks like this, right? Because 1 was just used, so it's no longer the least recently used one. It is now the most recently used item. So now it's at the front or the rightmost side of our cache if we treat it that way. Now, after this get, we call put. But remember here, our capacity is at 2. Right now our cache already has 2 items in it. So when we call in another put, we're gonna look at our cache and see that, hey, since we're at capacity, we have to evict So who do we evict? We evict the 2, right? We evict the 2, and the reason is because it's the least recently used item. It's at the front of our cache, and now we add the 3. After we add this 3, we call on get, but the key that's provided is a 2, and there isn't a 2 inside of our cache. So we output -1. Then when we call on 4, we're going to put a 4, right? A key of 4 with a value of 4. We see again that our cache is at capacity. It has 2 items in it, so we have to evict somebody. Who do we evict? The leftmost item, the one at the front of the cache, which is this 1. And then we add this 4. So at the end of our operations, our cache would look like this. So hope that makes sense. Now let's talk about an ordered dictionary and how that works. Basically, an ordered dictionary allows us to do all of these operations in the exact same way that I just described it, where we're going to treat the most recently used item at the rightmost side of our dictionary and the least recently used item to the leftmost side of our dictionary. So let's break it down this way. When we have 2 operations, right? A get and a put. So when we're doing each of them, let's kind of go through the different scenarios. There's not many, but it makes it simpler, in my opinion. So when you call in a get, there's only 2 cases, right? The key either exists or it doesn't. If the key exists, we're gonna move that key value pair to the end of our dictionary because we just used it. It is now the most recently used item in our dictionary. And then we're gonna return the value associated with that key. If the key doesn't exist, just like earlier, we just return -1, yeah? And for put, there's also 2 different cases. The key exists or it doesn't. If the key exists, we're gonna update the value associated with the key and we're gonna move the item to the end of the dictionary because we just accessed it, right? We're updating the value associated with the key. We're gonna move it to the end of the dictionary because it's the most recently used one. If the key doesn't exist, that means that there's 2 cases here in this subcase. Remember that we have a capacity in our cache. If we are at capacity, like earlier when we said that our capacity is 2, well then we're gonna remove the frontmost item, which is the least recently used item, and we're gonna add the new key value pair into the dictionary. And actually I think once we add the key value pair into the dictionary, we should also be moving to the end of the dictionary because when you add into the dictionary, actually I think an ordered dictionary will do this automatically. But anyways, so exploring the second subcase, right? What if we're not at capacity? Well, then we decrement the capacity and then we just add the key value pair into the dictionary, which actually, yeah, I think it automatically moves it to the end. So I'll refer to this as we code up the solution. But let's get into that actually right now. So what we're gonna do is, I've already imported collections in here, and when we're initializing our cache, let's just set the capacity to whatever is being passed in. And I'm gonna call this our mapping, right? I think it's ordered dates like that. Yes, ordered date just like that. Okay, so when we're going through the get, there's 2 cases. does the key, either the key exists or the key doesn't exist, right? So if, let's do the case where it doesn't exist. If key not in self.mapping, right? So if the key is not inside of our dictionary, then what we're gonna do is we're just gonna return -1, right? Like we said earlier in this diagram, if the key doesn't exist, you just return a -1. Else, that means the key exists. You're going to move the item to the end of the list, and I think it's move to end and return the value associated with that key. I think it's move to end here. Let's see. Move to, yeah. There's this move to end function here. Great. Okay, so now when we work on the put, either the key exists or it doesn't, right? So when we call on this one, let's say the key is inside of the dictionary. If the key is inside of the dictionary, then let's see. I'm just reading the diagram I wrote out earlier. Okay. So if the key's in the dictionary, we're just gonna update the actual value associated with that key, right? This is gonna update it, and then now after we've updated, we have to move it to the end because we just used it, and we want to make sure that it's our most recently used item at the rightmost side of our dictionary. Else, okay, so if the key is not in our mapping, what does that mean? Well, let's look back at our diagram, yeah? Either we're at capacity or we're not at capacity. So let's do the first case, yeah? If self.capacity is equal to 0, meaning we no longer have any space, we have to evict the frontmost item. I think we can delete. Oh, actually, I think it's a pop. Pop item. Yes, okay. So we're gonna pop the item and set last equal to false because we want to pop off the first item in the stack, which is the leftmost item, right? Now here, else, that means that capacity is not equal to 0. We can decrement our capacity because since we're adding something in, we have to make sure that we subtract 1 off of our current capacity. And then we're going to add this into our dictionary, right? Mapping key is equal to value. And actually, here, this case, we're actually going to do this with both of these conditions, right? Because since this is a put, if we're at capacity, we want to evict and still add the item in. If we're not at capacity, you're going to evict. Sorry, if we're not at capacity, you won't evict, but you'll just decrement the capacity, and then you'll add it in. You'll add the value in. So let's run this. What's going on here? Self.mapping equals collections. Ordered. Did I? Oh. It's ordered with a capital O. Great. Nice. Okay, this works. So if you're studying for a TikTok interview, I hope this helps, or really just in general. It's a pretty good question to know. There is a, so you're probably wondering like, okay, if I don't use collections, how do I do this? If I don't have an ordered dictionary, how do I go about doing this problem? And there's a way to do it with a dictionary and I think a doubly linked list, where they store values and you can kind of like access nodes really quickly and move them back and forth and skip stuff and whatever. But you can probably just look that up in a separate video. This is how I like to do it. I think it's really simple. The code is really short and it's pretty straightforward. So yeah, hope that helps.